Welcome back to my YouTube channel. I'm just going to wait here for a little bit. So if you're watching this after, I'm just waiting so that people can jump on. So I can say something. I have two screens set up now, so I'm able to hopefully do this a lot better than I did before. Hi, Noah. I had a great Easter. It was very different. Didn't go shopping for the candy until the day of Easter. So Sunday morning, I went to my weekly grocery store trip. And I got candy at half off, so it was great. It was just fantastic. We did an Easter egg hunt. It's cool. Maybe other people will join. I don't know. But no, you can appreciate this. I learned a new TikTok dance. And that's this, and then it's the Hi, Nadia. You got to see part of the TikTok dance. I learned it last night. I'll just wait for a few more people to join in. What's up, Tucker? It's a wonderful Monday. And I just realized you said good morning. So, hi, Nia. So, I'm guessing you just woke up. I was mom. Sorry, of course I'm a mom, but I had to do homeschool this morning. So that was fun. We learned about perimeter and area in second grade math. We made it out of Legos, so it's nice. It was really good. It was really great. All right. I'm going to get started here. Hopefully you guys have taken the test. If not, please do so. I have not gotten it all graded. I know I should have, but I did not get it all graded. So I will today or tomorrow get stuff graded. So today's or this week's schedule, I'm going to show you first. So let's look right here. Let me switch. I got a double screen now, so I hope this works better. Oh, look at that. It's all you can see. This is perfect. Okay, so right here, we have this week's schedule. So I know today is a day off. Thank you all for showing up. I'm trying to get to, oh no. Can I not go back over? There we go. All right. Nia, it should only be like a half an hour, okay? And you can hop off if you need to. That's fine. All right, so schedule for this week. I know today was a day off, so thanks for showing up. We are going to talk about really 4 standards, honestly, but they kind of broke them up, so it probably would only be 2. There is a homework assignment, but it's more so if you're still struggling with the greenhouse effect. It's right here. I really tried to find some other online ones. It took me forever. All of them were something you had to download, and we've had a struggle with downloading, which is not your all's fault, and I apologize for all the issues with the testing. I did not mean for it to be this difficult, but we're all doing what we're doing. You guys have been so gracious and wonderful, so I appreciate that very much. But if you need to explore the greenhouse effect a little bit more, here's some stuff right there. I had a PhET simulation. In class, we would be playing a game, actually, with these little yellow puff balls, which would emulate the sun. I tried to find a video for that, didn't have it, so this is what we got, you guys. So we'll talk about it today. Tuesday, Wednesday, you guys are off. Time to work on stuff, relax, do your other classes, whatever you need. Thursday, I'll have a video posted. I'm probably going to post it before Thursday. That way you guys can work on stuff ahead of time if you want, or it'll be there for Thursday if you want to work on it Thursday. Whatever's up to you. I will have office hours. I haven't figured it out yet. It's probably going to be, it's either Zoom or Google Hangout on Thursday from noon to 2. If you have any questions, you can hop on there. So I'll leave that open. And then there is an assignment for this week. It is an explanation over global climate change. So I'll spend a little bit of time going over that maybe at the end. I said I will be available from 12:30 to 2. I was going to do like a separate thing for my CP kids, but I might just have it full open hours. All right, so there's one assignment due for this week, and that's this explanation over global climate change. Please, a reminder, lots of us have not actually started, a lot of us have not actually turned in assignments yet. So let's make sure that we're sending emails of the graded assignments. I have started putting grades in. A lot of us are in CCP, and that's Cincinnati State. So I don't go based on Princeton's rules on that. So please still be working. And then the rest of you guys are in an AP class. So all this stuff is important for AP, whether you're taking the exam or not. I know this stuff isn't on the exam, but all right. So let's get down to notes. And you guys can ask questions. I can see them separately now because I've got this. So let's look at ozone. All right, so we've talked about tropospheric ozone. We've talked about stratospheric ozone before as well. Uh-oh. You guys can't see it, can you? Will someone send me a little message if you guys can see it saying stratospheric ozone 9.1 and 9.2, please? I may have spoken too soon when I said I had it all figured out. Hi, Aiden. Okay, I'm just waiting on someone to let me know if it's just a black screen for you guys or if it... all right. But you can see it now, correct? Okay, this is not what I anticipated. I wonder what's going on. Can you see... Can you see it when it's small? I love technology. Okay. Let me try this again. Why is it doing that? Very frustrating, you all. Let me try and get it. All right. We're going to make it this big because this is as good as we're going to get. All right. So stratosphere ozone, we've talked about it before. We know that it protects us from ultraviolet radiation. So here's how we get it in terms of talking about the scientific equation for it. We have 3 O2s plus ultraviolet light, which basically that ultraviolet light breaks up the O2 molecules, splits them. That ultraviolet light also helps them combine into O3. Sorry, Aiden, you guys missed that sarcasm for sure. All right, so we're absorbing ultraviolet radiation, which helps us because we won't get cancer, we won't get sunburns, we won't get cataracts, there's not going to be immune system damage to food, damage to the organisms creating food, crop damage, all that. Now, we can still get sunburn, we know that, but if there was no ozone in the stratosphere, which remember is the second layer of Earth's atmosphere, we would be in some serious trouble. So let's look at what's happening because we know that there's a hole, and there's a hole near the Arctic, and we're going to talk about that a little bit more because I found some research more recently about what's happening of the Arctic right now. So we are using, the main thing is chlorofluorocarbons, all right? Or we just call them CFCs, and I know you guys have heard that before. And remember we talked about just the fact that why it's happening in the Arctic is because there's these special ice crystal clouds that for some reason that are found in the Arctic. Okay, it's colder there. They're at higher altitudes, and so those ice crystals basically concentrate that extra UV radiation. And so it's not that there's more pollution in that area because we know there's not a lot of people living there, but it's the fact that those ice crystal clouds are intensifying the reaction that's happening. So here's what happens. We get ultraviolet light, obviously. Those chlorofluorocarbons are out there. That ultraviolet light hits them, breaks off a chlorine. Then that chlorine comes in contact with an O3 molecule, and it steals one of the oxygens. So then we get ClO plus O2. And so at this point, and then we end up having another reaction where another oxygen molecule will combine with that, and we get Cl and O2 at the end. So you're not only getting rid of one ozone, you usually are getting rid of two at that point in time. So that's a problem. We'll talk about the Montreal Protocol in a second. All right, let's look at it visually. All right, so this is a chlorofluorocarbon. We have UV radiation that strikes it. It kicks out basically a chlorine. All right, that chlorine then takes away an oxygen from O3. All right, then there's another single oxygen molecule, oxygen element, atom, that will knock that off. So then now we just have chlorine and O2. So we've really messed up a lot of things by adding that in there. Ozone is being constantly created and destroyed in there anyways. So in this situation, this is now destroying it faster than it's being recreated, because ultraviolet light is going to break them up and then bring ozone back together again. So what we're doing is increasing the amount that it's going down. It's decreasing by. So this is just an image of what it looks like. So a lot of people like to say it's a hole, but technically it's just a thinning. There's not an actual hole, but that's just semantics. Here are some pictures. These only go up to 2007, but it kind of shows the fluctuation. So the blue color is a lower amount of ozone. The red color would be more. So it's fluctuated over time. And here's just another image showing it. But where is this? Right here. All right. There is, right now, there is an opening over the Arctic that hasn't happened like this since 2011. And from what I read of this article, and you guys can go back in and read it yourself because those notes are on there, what's happening is the temperatures are dropping due to climate change. So yes, we know climate change we can also call global warming. The whole Earth as a whole is warming up, but we know that this shifts the different biomes. So it's actually making the Arctic colder, which allows there to be more higher altitude clouds, which is these ice crystal clouds, which is going to intensify the ultraviolet radiation, which then intensifies the destruction of ozone. So you can go in and read a little bit more about it right now, but I was kind of surprised that was happening just because we're seeing much less pollution in other places. So just something to look at. Now, where do these ozone depleting chemicals come from? Coolants. So coolants are, you got a coolant in your car, you got coolants in your house, you got coolants in the fridge, freezer, all that. It was in spray bottles, but because of what we'll talk about next, or in 2 slides, those kind of went away a little bit more. Bubbles in plastic foam. If you've ever had someplace fumigated, or if you've heard of it, it's usually trying to get rid of bugs or whatnot. That has it in there. It's in fire extinguishers. So you can see these other ones that have chlorines in them. Well, that one doesn't, I'm sorry. But the hydrogen chloride and whatnot, those also can destroy it as well. But CFCs are the one that they always focus on. All right, so what's going to happen if the ozone is depleted? Well, you as a human being can get sunburn, you can get cataracts, you can get skin cancer. It can suppress your immune system, which would be terrible right now with what we're going through. Same thing can happen in the wildlife. You can get cataracts, all that. There's going to be less phytoplankton, so there's less dissolved oxygen, which would then disrupt the food web. It does create more photochemical smog because we know that ultraviolet radiation, that UV comes into play more with the smog. Now, because there aren't as many cars, probably not going to happen right in this moment for us. But we do know that's a possibility when there are cars around. Also, CFC is a greenhouse gas. So we'll talk about that next on our next set of notes. It will reduce the yield of our food. It reduces seafood because of the less photosynthesis happening. because they can be sensitive to that. So let's look on some of the laws on ozone depletion. So in 1987, long before you all were born, but the year I was born, there was a Montreal Protocol. So in Montreal, they met different world leaders, and they discussed cutting the CFC emissions by 35% from 1989 to 2000, which they did. They did a good job. It actually has decreased. And then the Copenhagen Protocol happened in 1992. They accelerated the phase out so that it would just happen more quickly than what they had originally planned. And then they went back to Montreal in 2007 and kind of they tried to phase out the thing that they used to phase out CFCs. So they got rid of the HCFCs that they thought would work, but also depleted the ozone. So what they're trying to do is phase all that out a little bit more. So that is ozone. Major highlights and takeaways. Ozone is necessary because it protects us from ultraviolet radiation. Ultraviolet radiation can cause cancer, immune system issues, and sunburns and reduced productivity. All right, so UV is bad. Ozone protects us. It's happening near the Arctic because of these special ice crystal clouds. The products are CFCs mainly that are causing this depletion. And so that is the ozone information in a nutshell. If we want to look here, just so you know, I did put the new unit Google Doc on here for all the information. We'll look at it real quick. All the standards we're going to cover, and we're going to take about 3 weeks to cover these. And then you can look a little bit more in depth at the 4 that we're talking about. These are the first 2 that we talked about right here. And then we're going to talk about the greenhouse gas effect. Okay? Or the greenhouse effect, excuse me. All right. Let's just see if this one presents correctly. Nope. Okay. Perfect. Only not really. All right, so it's not really chapter 19. I actually don't know what chapter it is. I just left that because I grabbed this PowerPoint from someone else. All right, so these are some things that you might want to go back to see later on if you can answer all these for global warming and ozone depletions in here as well. So you're going to want to know chemicals involved, the human causes. We should know the layers of the atmosphere and where they're happening. Global warming would be where we are. Ozone depletion is in the stratosphere. The environmental effects and the human health effects. So make sure at the end of this whole video you can answer all of this. All right, so this is part of the global change unit. So this is only parts of what we're going to talk about, but a lot of it is climate change. There is going to be some animal stuff in here and endangered species as well. And so we'll get into the ocean acidification and the sea level rising and that temperature later. But, and there's a lot in this PowerPoint. There's extra than what we're going to talk about. All right, so we have had historically patterns of our temperature increasing and decreasing, and that has coincided with the amount of CO2. All right, so we've discovered that CO2 plays a role in our Earth's temperature. It's not the only thing, but we've seen a strong correlation. So we've seen this fluctuating up and down, but we do know that our levels are a lot higher than we've ever seen them. So we've talked about this. I want to go through it kind of quickly. Because we've talked about climate already and we know what impacts our climate, and there's a lot of different things, but a major player in this is the greenhouse effect. All right. So if you've ever been to the Crone Conservatory or any conservatory or greenhouse, you know that when you walk in, it's warm, it's muggy, it's kind of feels like you can't breathe. And that's because it's keeping it warmer based on the idea of the greenhouse effect. So we'll look at that. All right. Instead of, you guys can go back to this, but I was going to draw it out. I grabbed a new Chrome extension and have no idea how to change the color. So I guess, oh no, there it is. Yes. All right, we'll start with green. All right, so this is going to be our Earth. It's still red. There we go. All right, here's going to be the Earth, right? So then we have our troposphere, which is where we live. And we have all these gases, all right? There's a lot of carbon. We know there's CO2. There's more. We'll talk about them later. So I'm just going to do the major players. that we always talk about, and CH4, so methane. All right, so we've got CO2 and all that. All that's hanging out up here. Now, we have the sun, right? The sun is releasing UV rays, right? They go into the ground. Some of them get reflected back by clouds. They get reflected back by air droplets. They get reflected back by a lot of things. So not all of it reaches. Some of it goes into photosynthesis, which is less than 1%, which we've talked about. But some of it goes into the ground, all right? And so we've got this ultraviolet radiation now in the ground. But as we know, when we transfer energy or energy changes forms, some of it gets lost. This is the first and second law of thermodynamics. So energy is neither created nor destroyed, but it can change forms. And when it changes forms, it gets degraded. So here's what happens. The ultraviolet radiation goes into the ground. The ground will then re-radiate it out. But this time, when it re-radiates it, it is a longer wavelength and a lower frequency. Higher frequency, shorter wavelength, which means UV is stronger. This is now infrared radiation, okay? Basically heat. IR stands for the infrared radiation, it's heat. So UV is able to go through the greenhouse, right? These greenhouse gases, because it's really strong, it's powerful. But infrared gets blocked. And so it is reflected back down because it can't get through these gases. All right, and that's what happens. It happens in your car. So if you've ever gone out after school one day and it's a spring day or a fall day and it's been really sunny, but it's still kind of chilly out, and you open up your car, it's hot inside. That's because all of that heat got trapped inside of your car. Your seats took in that ultraviolet radiation. It re-radiated it back out as heat or infrared radiation, and it got trapped inside of your car. That is the greenhouse effect, right? The greenhouse effect is super important. If we did not have this, you guys, we would be freezing, all right? So the greenhouse effect is really actually very beneficial to our Earth. It keeps it at a nice, consistent temperature. We wouldn't be able to survive. There's a lot of planets that don't have that, okay? They don't have a greenhouse effect. And so they're a lot colder as a planet. So this is actually really beneficial to us. But the main point here is that we have ultraviolet radiation coming from the sun that gets past the ozone layer, gets absorbed into the ground, and then gets re-radiated as a lower, it has less strength, okay, as infrared radiation that gets trapped in by these greenhouse gases. All right. Okay, we're going to move on from that drawing. Right here, if you want to go back, that just kind of states that out again. So let's look at what are our greenhouse gases. Well, actually, crazy enough, water vapor is a greenhouse gas. Now, there's just not enough of it, and it doesn't stay in the atmosphere very long, so we're not really concerned about water vapor. Carbon dioxide, we are concerned about. And we used to be the most concerned about carbon dioxide. But what turns out is that methane, although a lower concentration, of course, this is 2010, we'll go based on that, a lower concentration than carbon dioxide has a larger impact. It can absorb or it can trap more infrared radiation. Why? I don't know. I just know that it can. All right? Don't worry so much about the duration of the atmosphere, but just saying these things are not good. So some other ones, although the key ones, again, carbon dioxide, methane, kind of the main ones. But then there's nitrous oxide as well as chlorofluorocarbons. All right? Those are all the greenhouse gases. Now, just to review a little bit, our climate does not just depend on the greenhouse effect, but that is a huge part of it. Okay? We also have ocean currents, which we talked about. So the colder waters from up here, colder waters from right here try to go to the equator. The equator's warmer waters try to go to the poles. And so we get this kind of nice balance of temperature. Not going to go through ocean temperature changes. Okay, we may end up looking at this data a little bit more. Or there might be another one that we're going to do for next week when we talk about ocean temperatures and ocean acidification. But this is just kind of interesting. So we're looking at the overall trend and then monthly averages of CO2. So the overall pattern since 1960 is that they're increasing, right? But there's some oscillations, and the oscillations that they're talking about are this up and down of the monthly averages. And why does that matter? So we'll go to the next slide. So why does it actually oscillate? Well, it's because during the springtime in the northern hemisphere, the plants are doing a lot of photosynthesis. We know we have plants growing. My tulips just came out. We have trees coming back to life. We see all these things, right? That is increasing the uptake of CO2, thereby reducing the global CO2 concentration, right? Now, of course, we're talking about in the northern hemisphere. But we know also that the northern hemisphere has a majority of the plants because it has a majority of the land. So that's why we see these changes. In the wintertime, the northern hemisphere, everything dies and decomposes. So it releases CO2. Not only can it not take any in because things are not growing, but also there's decomposition, which we know those organisms that are decomposing use up oxygen and they release carbon dioxide. So then we're going to get an increase during that time. So that's what the oscillations are showing. All right, what are we doing? How are we impacting these greenhouse gases? And why is this going crazy right now? Well, you guys know that we're burning fossil fuels. We know that cars emit CO2. We know that factories emit CO2. We know that we're emitting nitrous oxides in our cars. We've talked about that with the cars being, when we talked about smog. All right, deforestation means there's not as much CO2 that can be taken in. Cutting down the trees doesn't just suddenly release all the CO2. It's the fact that it's not taking in any more CO2. We have inorganic fertilizers. That one, to me, isn't as big because they don't typically get airborne. Landfills are releasing CH4. CAFOs. You guys love to say CAFOs randomly. So here you go. CAFOs, those livestock feedlots, cows farting is producing lots of CH4. It seems ridiculous, but you only need small amounts of CH4 to make a huge difference in terms of the greenhouse effect. Rice paddies is really random, so if you don't remember that one, it's literally not the end of the world, but it does produce CH4. I don't actually know how. And then we have smelting, which is an industrial process that can release stuff. That is a problem. That's at the sulfur. All right, talk about the global warming, greenhouse effect, and the carbon cycle. So we know that there's carbon. There's a lot of carbon in the greenhouse gases. So this is just discussing what is taking it out, what is releasing it. And so with that, this carbon cycle moves us into feedback loops that we talked about at the very, very beginning of the year. And remember, positive feedback loops keeps the cycle going and going and going and going, and a negative shuts it off and makes it stop. So we're going to look at some examples. All right, so CO2 levels are going to increase. Scientists aren't sure yet if that is going to increase photosynthetic rates or decrease them, but we do know there's probably some type of range of tolerance there or amount, right? Because we're going to have other things that are limiting factors. So photosynthesis rates could increase if we don't have any other limiting factors in the situation. Carbon is only stored in the plant until it dies. Trees may temporarily slow CO2 emissions in the northern hemisphere. I want to look at the other feedback loops though. That was just talking about particulate matter. It can cause global cooling because I'll go to it anyways. Particulate matter like aerosols. What can happen is we can have water sitting on those aerosols, which would then basically reflect the sunlight back so it won't hit the earth and therefore it won't turn into infrared radiation and won't get trapped. I know I'm coming up on 30 minutes, so I'm going to hurry. The albedo effect. So we talked about albedo. We know that darker colors absorb more radiation, lighter colors reflect. So as ice and snow melts, because of the warmer temperatures, right? That means there's going to be less light reflected, more absorbed because the darker soil underneath. So if more is absorbed, more is released as infrared, more getting trapped. So our temperature increases. So this would be a positive feedback loop. It's going to keep continuing. As the temperature rises for oceans could absorb extra CO2, leading to a decrease in global warming. but more acidity. Or it could really end up leading to more CO2 being released because the temperatures will warm in the oceans, which we know, just like a pop gets flat, if it's warm outside, it's going to release more CO2. Cloud cover. So as temperature rises, cloud cover increases because there's more evaporation. So it could have two different effects. It could have a warming effect by trapping in more heat. Generally at nighttime, that would be the thing. But they've also seen a cooling effect because it blocks more sunlight. Cloud cover is the one thing, at least from what I've read in their models, that is just too variable and is kind of hard to pin down what's going to happen with it. So this could be either a negative or a positive feedback loop. Permafrost. So permafrost is in the soil, like those tundras. When permafrost melts, it actually has methane trapped in it. So this is going to be positive, causing a higher increase in temperature, melting more permafrost, releasing more CH4, causing a temperature to rise, and so on and so forth. This is showing the difference there. Okay, so here's where I'm going to stop, take a step back, show you what your assignment is, and you can look at the rest of the notes here for this, and I am also going to have a video. So the assignment that I'm going to have you do this week, first off, make sure you understand these first 4 standards, and then it's going to standard 9.5. So there's really 5 standards for this week. All right, so make sure you go over them, look at the notes again, ask me any questions that you have. Thursday I'll be on Zoom or something, I'll post it up. And then this is your assignment. So this is going over standard 9.5. I'm going to share a video with you. But your goal here, you guys, is to describe global climate change. And so I've given you a little bit more information. You can refer to the past and then this present situation. Then you're going to explain. So remember, describe. Describing is just like giving an account, basically like a picture with words of what's happening. Explaining is now going into details so that someone understands, right? So think about explaining global climate change to a denier or something, right? And then you're going to talk about it in terms of its impact on the changing climate and the ramifications there. So you're going to go like a little bit more in depth, and you're going to make a connection of what's occurring right now in real time. Now, here's something really important. This is not supposed to be exhaustive. Okay. The goal here is that you guys understand a little bit more about climate change. I can also see if you guys have any misconceptions when you explain it, but also to do some explaining because this is a scientific practice. So do not go crazy. Focus on one aspect of global climate change to describe and explain and then expand upon instead of trying to do absolutely everything. Here's the information, and this is from this is just the standards. So you can pick something out of this, right? That's a long list. Pick one thing, right? And I will have a video and notes to go over it. If you have any questions, please, please, please let me know. I'll sit on here for a few more minutes to see if you guys type any questions out so I can answer them right now. Otherwise, you guys can do the online greenhouse gas assignment, any other assignments that you need to make up. And you can get started on the climate change. I promise I'll have a video up hopefully tomorrow. You don't have to do it until Thursday. I'm going to give you guys till Monday. Let's be honest. You guys really have all the time until we actually have to put final grades in, but don't wait all that time, please, for all your assignments. But let's go Monday for this explanation one. All right. If you guys want a due date, Monday for that. Please take the test if you haven't taken it. And please do any of the work that you guys haven't done. And I will wait to see if you guys have any questions. Aiden, I'm hopefully going to get that done after I click off from here or Tuesday. I've already gotten a lot of people's, it's the FRQs that are taking me a little bit longer. While I'm waiting for your questions, I'll show you guys the new TikTok dance I learned. I forgot the rest. Okay, this one. Let me go. I feel like if Asia and Ariana were here, they'd be so proud of me. questions? All right, if there are no questions, which is totally fine, I'm going to end this stream and it will be up. Ask all the questions you want. This is the only live stream for the week, so you guys are done with that. I'm just going to post a video and I'll have office hours on Thursday, so be looking for those two things. Miss you guys. Can't wait till this madness is over.